Hey everyone, welcome to the third session of Jadu Gaif. And today we are going to talk about some databases. But before we start, the admissions are about to close. And before they close completely, I just want to give you a quick demo, a quick overview of who we are and what do we do in case if you're someone that just joined Jadu and have no idea about what exactly is Jadu. So let me share my screen and I can give you a quick idea of who we are. So yeah, Jadu is actually a fellowship program, which is a 4 weeks of program where we helps young people into the tech industry. So yeah, so Jadu is founded to empower students with the mentorship and career opportunities with the help of Google experts, young entrepreneur, etc. We help you to get into the tech industry. Our vision is to help young students and young brains to get into the tech industry by getting a job as a software engineer, program manager, etc. Uh, so just to quickly summarize, what we are providing is so Jadu is basically providing fellows more than the training, which includes like technical sessions, mentorship classes, projects, Q&A sessions, community sessions, etc. Now, what exactly they are? Technical session is about everything about coding, which includes. So currently we are highly focused on web development, but you can expect some more tracks in the future like AI, blockchain, etc. So technical session is all about web development. Mentor session is all about soft skills like project management, time management, etc. And projects. In the project section, we have projects for to build your technical portfolio, which will includes different kind of project that you can showcase when you are applying for the jobs. QA session, something very important when you have some kind of question. So we do have a QA session where you can ask all those questions and clarify that. We strongly believe in building a community. That's why we do have like a specific dedicated sessions for community building. uh, what do we cover in the front end development includes, as I said, we are highly focused on web development at the moment, and in the web development we are highly focused on web front end. So in the front end, what we are teaching is HTML, CSS, JavaScript deployments, different kind of deployments, like how to deploy your front end application to different websites like GitHub, Netlify, Vercel, etc., including Firebase, how to use Firebase as a database, and how to use Git and GitHub. Of course, the essential one, the very essential thing for a software developer. With that, we do focus a little bit on backend as well, so that you have a good idea of like how things work, how can you um, how things work in like how can you connect the front end with the back end, and how engineers coordinate. So where by the end of the fellowship you will have a very good idea of how everything works. Here are some of the example of our mentors. Yeah, so here are some of the example of our mentors which you can see. So we have Google developer experts, we have CEOs, we have a well-known people from a well-known companies, and that is almost it. Here are some of the links. Jadujobs.com is our website. Our LinkedIn page is linkedin.com/company at Jadujobs. We do have a public Discord which you can join. I did show you some of the mentors, and if you're interested to know more about the mentors and who are the team behind the Jadu Jobs, so please go to jadujobs.com, and there you will see a brochure which has all the details of who are the mentors, who are the people behind Jadu Jobs, are the FAQs that you might be thinking about, and everything that you want to know. So just visit jadujobs.com and go to the brochure, and you will get all of the answers. And with that, one last important thing that is about the admissions. So the admissions are currently open, but the last date is 25 January. So if you're someone who has not registered yet and who has not applied yet, so please do so as soon as possible. And again, here is the Discord link, and it's also available on our website as well. So feel free to join that. And Yeah, if you have any question, feel free to post it in the comment section right now, in YouTube, Facebook, or LinkedIn, from wherever you are watching. So with that, I am going to now introduce you to our today's guest, who is Kinza Sheikh. Kinza Sheikh is currently working as a database engineer at Kareem, and today we will be talking about databases. So let me add her to the screen, and then we can move forward with her. Hey Kinza, am I audible?
Hello, Arslan. Yes, you're audible. How are you?
Awesome. I am doing good. How about you?
I'm doing excellent. Thank you for inviting me.
Awesome. All right, the stage is yours.
Okay, so let me share my screen. Um, hmm, is it visible?
Yep.
All right. So today we will be discussing about high availability databases and some of its more extended features such as clusters, replication, and failover. But we'll get to it in a moment. First of all, I will share with you my experience into getting to a, to a professional world or professional experiences over the last few months, and how after graduating, I was open to a whole new world of features and practices that we follow that are not really that was not really taught, or maybe I did not learn during the undergrad life. So we will be discussing about high availability databases because it's something that I have recently, I have been working on it recently, and I also found it really cool, like a really cool concept to implement. And that is definitely one of the most important features of software solutions while you're deploying software solutions uh, to production environments. That is something that is probably one of the most important things to keep in mind while you're working with the while you're working with the high availability systems. So as a students, while we were learning about databases, we learned about how to design databases and how to query them and the different type of architectures and etc. But there are certain more features of which are part of the designing and solutions that are majorly overlooked while we are working with it. And high availability is one of them. Like scalability and performance optimization. These are these are few of the features or qualities of a software solution that are far more important that is than they are being considered these days. So while you're deploying your solution and you go out in the market and you launch an application, and you find out that your application is actually doing really well, but it quickly becomes a problem because your solution is not optimized to deal with the increasing amount of users. So that is where these features or these quality attributes come in, because they are there to make your solutions actually reliable, make your solutions actually accessible to the users. So we will get to it. We will explore more of what is high availability and databases later. But first, I'll explain a bit about myself. So I'm currently working as a database engineer at Kareem, where I work with some really cool technologies about provisioning and managing database solutions, and provisioning scalable and robust and high availability systems, which I'm going to talk about today. Along with that, I am also, occasionally also write about those technical things. Um, so basically, so I also have a few, like blogging activities going on along with all of the technical stuff I'm doing, and because I love writing, so that's where I put my writing tendencies towards. And thirdly, I'm a tech nerd, and so is everyone who is here, because otherwise we wouldn't be here on a weekend in a tech session and talking about tech stuff. So next, so so today we will be talking about a few things which mainly revolve around high availability and high availability in databases. So firstly, we will explore what high availability actually is, and then we'll move on to databases, and then we will talk about how to achieve high availability in database systems, and then we will talk about database clusters, which is a really cool concept, and then we will talk about more soft clusters, the different type of clusters which we can, like make or use. And then we will talk about replication, failover, and the working and how the failover actually works. So let's start with high availability. So high availability is basically just a characteristic of a system which makes your system, which ensures your system is available to the users when they are trying to access it. So uh, when you listen to the word availability, it's just basically the availability of a system to be able to provide service, or to be able to be of use to your users when they want it. And when you combine it with high availability, it means that your system is available most of the time, almost 24/7. But since being available like all the time is really impossible. So we try to maximize availability as much as we can and minimize downtime. And this is what is high availability is all about. Just minimizing the downtime of your system. So once you're designing a software solution or putting out a application out there, and if it's a really cool application, and it's offering a lot of features to your users, but if your user is trying to access it at a time and it's not accessible, then it's quickly going to lose its credibility or its charm, because it is not available to the users when they want to use it. The user want to be using an application which is reliable, which can be available to the user all the time. So it can get frustrating to the user if your application just is having a lot of downtime, and it is not, like it's just disappearing quickly, or if suddenly the amount of users of your application is increasing, it quickly becomes, it gets a downtime because it cannot manage the amount of users that is coming onto the application. So that is what high availability actually is, and that is why we need to really consider it and keep it a part of our systems when we are trying to design our systems. Uh, so next, so the availability is generally measured in the nines. So this is like the standard measure of availability percentage, where you measure the availability in the number of nines. And what does it mean is that there is your availability could either be in 1 9 or 2 9 or 3 9 or 4 9 or 9 9s. So if it has 1 9, it means it is 90% available. And what does 90% availability actually means is that the amount of downtime your application sees within a year or per month or per day. So if your application is 90% available, it means that it is going to be it's going to see a downtime of 36.53 days per year. And that means like 73.05 hours per month and 2.40 hours per day. So you can imagine that if you're trying to use an application which is down like 2.4 hours per day, that it is not a great application. Because if you're if for example, if you're trying to use Facebook and it is down like 2.4 hours a day, that is going to get extremely frustrating, because who's going to wait for the application to be back to normal and use it? You're going to shift to another application. You're just going to use an application which provides a higher level of availability. So there are actually higher level of abilities like 3 nines, 5 nines, 7 nines, or 9 nines, which makes much more sense when you are trying to consider availability in your system. So 3 nines mean 99.9%, and it's 8.77 hours per year downtime, and 43.83 minutes downtime per month, and 1.44 minutes downtime per day. It is still pretty much, like not great, because when your application is pretty much used by a lot of users, you need to minimize the downtime to, maybe like uh, in microseconds or maybe milliseconds, because that is what is going to be acceptable by the users. So we have the highest availability level available, which is 9 nines, which is like 99.9999999% available, and it offers just 31.56 milliseconds downtime per year. As you can see, that it is that that is what your application should try to achieve. That is the level of availability your application should try to achieve, and that is how you can actually retain your users, because they would really like it when your application is available all the time and it's not showing them downtime like every day or even every month. So this is just a basic chart of the availability percentages, which is used to measure your availability for the systems. And then we have next slide. So why is high availability actually important? So like we have been talking about the importance of high availability even like before this slide appeared, but we will specifically start talking about it now. And why is high availability important? That is because it offers service continuity. So, what is service continuity? Service continuity is basically the continuance of service which is offered by high availability in your application. So, so again, it's the same concept that if your service is highly available, it is going to offer the service continuously, and it is going to be available even if the load of users is increasing or decreasing. It doesn't really matter what is the level of, or like how many users are currently on your application, or any other factor that might make the availability of your system affected. It really is not considering that those factors much, but it is going to offer the service continuously no matter what. So once your application is offering its service continuously, it becomes high available, and that is what you're trying to achieve with implementing high availability in your systems. Because service continuity is one of the most important concepts in your service. The second thing that why have high availability is important is data integrity. So if your system is suddenly goes down, then there is bound to be a lot of data loss, depending on the amount of downtime, on the like the length of downtime your application faced with your faced. So if there is a very long downtime, there's of course going to be a lot of data loss, and even like a lot of users might be trying to retrieve data or enter data into your application, and they would not be able to do it because your application is down and it is not available. So data integrity might get affected if your application is not highly available, and if it's you know and even like with other concepts of replication, and which we'll be covering later on. If your system is suffering from lower availability, the replication is bound to get affected, and uh, that is going to affect the data integrity consequently. Also, why is high availability important is because it conforms to SLAs. So SLAs are service level agreements which you are offering to your customers or your users, and these days the customers want to want to see the service level agreement that your service is offering and how much downtime you are adding to your service level agreement. So in order to make your service compliant with conform to the SLAs, you need to keep your service highly available, because that is what the customer is agreeing to with you while signing up for your services or while using your applications. So these are one of the 3 points which are the reasons why high availability in your systems is really important, and there are several other reasons why high availability is one of the most important things you could incorporate in your systems. And that would also ensure business continuity, because if your application is not highly available, the customers are bound to shift towards another application or service which is available, because customers really don't care if how awesome your service is if it's not available. So we saw that Facebook went down for a couple of hours, a couple of months back, and everyone started talking about it on the internet. But they were talking about it on Twitter. So we saw that even though a lot of people use Facebook, when it was unavailable, the users shifted towards Twitter. Most of the user base went towards Twitter, and that is because, and that just shows that if your application is not available, the users uh, are bound to shift towards another services, and that is going to affect your business. So next thing is we will be discussing about databases. So what are databases? Databases are a very very common concept if you are a tech student or a tech enthusiast or have even a little bit knowledge about what is it what about technical stuff. So database is basically a collection of data in an organized or structured manner, and you basically use databases to store your data in so that it can be accessed later on, because there are various other ways to store the data, but it becomes difficult if you have to access the data later on or modify it or do a number of other things on your data. So it becomes so databases are what offers the ease, like ease in accessing your database, accessing your data or modifying it or managing it or like updating it or stuff like that. So so databases are basically are basically a collection of a lot of tables, but that is not always the case, because there are different type of databases like relational databases, object oriented databases, and then there are NoSQL databases and geographical databases and distributed databases. There are a lot of types of databases. So the traditional relational databases offer a collection of tables where you can store your data in rows and columns, and you can perform a number of actions on your data through querying your database. And we can perform the query through a language which is SQL, and SQL can be used on the database to basically retrieve information or even perform like a data definition or data manipulation operations. So databases are so in a nutshell, databases are what you use to store your data in a organized manner. So how to achieve high availability in databases? So there are a number of ways to that you can achieve. Like there are a number of architectures and ways which you can use to achieve high availability in your databases, and that is um, so like that those are like redundancy, replication, and recovery. So what is redundancy? Redundancy is the repetitiveness of something. So when you are trying to achieve a high availability, the first thing you need to do is to eliminate a single point of failure. So if a component or any or a hardware or a software is the sole source of data or sole source of any service or anything for your system. And if it fails, then it is going to cause your whole system to go down, and that is what we need to eliminate from our system. So we use redundancy in our systems to eliminate the single point of failure from our systems. So if we have, if we have a single disk in our system, we could have, like many disks in our system to to eliminate disk failures, and we could have like multiple copies of data in case the data is corrupted or something, or we could have multiple servers in case a server goes down, or we could have like anything that has the potential of failure, and that would mean just about literally everything. uh, you can make a copy of that to achieve redundancy. So through redundancy, you can achieve high availability and consequently, and that is one of the that is one way you can achieve high availability. The second is replication, and replication is it extends on the concept of data redundancy. And when you have data in one place and you want to you fear that maybe that data could get corrupted, or it could basically become unavailable, or maybe the like the server on which the data reside could fail, or like it could have a disaster or something. Then you just simply replicate the data to more places or to more servers. So this is how you are able to achieve high availability in your systems. And if the data at one place is corrupted or something, you could just access the data from another place. So this is how this is how replication helps in achieving high availability in systems. And third point is recovery. So, so the redundancy and replication are something we consider before the disaster happens. And if the disaster occurs, we need to worry about how to recover from the disaster and get our system back to the availability as quickly as possible. And this is how and this is where we need to consider the recovery options in our systems, like maybe how your systems can quickly come back to life after a disaster has occurred, or how your system, like the minimum time to recover, and minimum what's the minimum time of recovery of your system, or how what is the maximum downtime your system is going to face if even if there is a disaster. So these are the things you need to consider, or you need to optimize if you want to achieve high availability in your systems. So next we will be talking about database clusters. So we talked about the different ways we could achieve high availability in our database solutions, but how do we combine all of that into something that actually offers high availability? And that is where database clusters come in. Database clusters are basically a collection or a combination of multiple nodes running a single database. So we need our database to be redundant, and to be able to support replication, and to be able to recover from disaster if there ever is one. So database clusters offer a collection of multiple nodes, and that is how they provide high availability. Database clusters provide high availability by combining all of those features: the redundancy, the replication, and the recovery mechanisms. So pop-up quiz, if anyone is willing to answer it: how many minimum nodes do you think are needed to form a cluster? So um uh, so nodes are basically, server instances which you can use in your system to support, the support replication, redundancy, and recovery. So I'm just going to answer it myself, that we need uh, minimum of three nodes to form a cluster. So cluster is basically just a single database residing on multiple nodes. And here you can see that we have node 1, node 2, and node 3. And the client app could just access the data through any of those three nodes. So So that is how we, this is where you see redundancy in your system. We have three nodes where the same database is residing, and we could just, in case of failure, you could see that we could just use any other node out of these. If a single node failure, we have another two nodes to support, or step forward in case there is a failure. So. Um, so there's a concept of a different type of nodes, which are primary nodes and secondary nodes, and basically, when you're in a cluster, all of the nodes are could act as the same type of nodes, or we could optimize the services of a cluster by by distributing the nodes into primary nodes or secondary nodes. So what is a primary node? Primary node is basically responsible to handle the read write request from an application. So when you're dealing with a database, the users could either send a write request or a read request. So when you're receiving read connections, that means that the database itself is not being updated or changed, or like updated or changed, or more data is not being inserted into the database. In that case, we just need to retrieve the existing data from the database and provide it to the users. On the other hand, the read write requests actually mean that the database itself is being updated or modified or altered in some way, and that's why we need to separate it from the read only request. So primary nodes are what we use to support the read write request of an application, and it's the primary source of data in a cluster. And that is where the replication originates from towards secondary nodes. So like we saw in the previous figure, we have three nodes in our system, and we could just, um, we could just, if we could just, like we have the same data on the three nodes, but if more read and write users are coming into the read and write connections are coming into the database from the client side, we need just a single source of data to to hold that read write connections, and to be able to deal with those connections and have them saved into the database. And once those read write requests are logged into the database, we could just originate the replication uh, towards the other nodes that are part of the system, and those nodes are secondary nodes. So we have primary node, and then on the other hand, we have secondary nodes. The secondary nodes are basically responsible to handle the read-only request. Now, secondary nodes offer two advantages. By adding secondary nodes along with primary nodes, we get two advantages. So one advantage is pretty much obvious, which we are discussing since the start of this presentation, which is high availability. So in case that a single primary node fails, so we have other nodes to support the connection request from the client to and cater to the needs of clients, and that is offered by secondary node in case of the primary node failure. Along with that, the secondary node also offers another advantage, which is the read scalability of the system. So if the primary node is receiving redirect request and also the read request, it's going to get a lot of traffic from the client application, and it will not be able to get to the needs of to increasing number of client requests, or like to an increasing number of users in the system. But if we add just another secondary node to our cluster, then we could just simply send the read request from the client to the secondary node, and the read write request could go to the primary node. So in this way, we could add as many secondary nodes as we want to increase the read scale of our application. Since since in most of the applications the read only requests are far more than the read write request, then we need a higher number of nodes to capture the need of read only request. So that is why that is how secondary nodes are basically enabling the read scaling of the databases. So here we have a client application which is which is sending connection requests to our two nodes. One is primary node and one is secondary node. So the read-write connections are going towards the primary node, and the read-only connections are going towards the secondary node. So that is pretty much what is happening in a cluster. That once you then once there the client app is trying to send connection requests to our database systems, we just divide the type of connection request our database is receiving towards the respective node that they are going to get to. So the next we have is modes of cluster. So there are basically two modes of cluster. One is active mode of cluster. One is active passive mode of cluster, and another is active mode of cluster. So active passive database clusters are also called multi-primary database cluster. Single primary database cluster. So in active passive database cluster, what is happening is that we have multiple nodes in our cluster, but only one of them is the primary, acts as the primary node and the only source of data in our cluster. So uh, once the read-write requests are coming into our cluster, those read-write requests are only directed towards just one single node, and all of the other nodes act as the secondary nodes in our cluster. So we have just one database coming into, so we have just one node catering to the read-write request, and all of the other nodes catering to the read-only request in our system. On the other hand, we have active database cluster, which is also called multi-primary clusters. And in active database cluster, we have multiple, or at least you can say just two. Give me a minute. Sorry, just give me a minute. So yeah, in active database cluster, we have at least two primary nodes. So when there are read-write requests coming into the database system, there are basically two primary nodes which are going to like cater to the needs of the client requests, which are read-write. And there could be more nodes which are read-only, but at least there are two nodes which are primary nodes. So next we have replication, and in replication we have replication is basically again the same concept, which offers redundancy in the data. So what's happening in replication is that since we have a primary node which is receiving read and write requests from the client users, and when there is data being written into the primary node, we need to shift that data to other secondary nodes so that all of the nodes could have the same data without having any difference in data. Because if there is a failure of the primary node, we need our primary node, we need the secondary nodes to shift towards the primary node, and if the data is not same on the secondary nodes, then it could become problematic for the clients or for the whole system. So this is what replication does. When we have data being written into the database system through the primary node, replication enables the writing of that data to the secondary nodes through predefined replication mechanism. And through replication, and once we have the replication enabled on secondary nodes, the secondary nodes could just about cater to any of type of read request that the client is offering. But because if the data is not in sync with the primary node, the read request could become faulty or could be wrong. The data that is being returned by the secondary nodes could not be correct if there is a replication lag in our cluster. So that is why we need an up-to-date replication mechanism in our databases. And this is how we also achieve data security in our systems. So there are two types of replication. There is synchronous replication, and then we have asynchronous replication. What is synchronous replication? It is basically when you are trying to write data from primary node to secondary node to achieve the similarity in data in your data on all of the nodes. The primary node basically waits for the secondary node to confirm that the data it has sent has already been written to the secondary node, and once the confirmation is is received from the secondary node, it sends more data that needs to get written to to the secondary node. So it's just so there is very little data loss in synchronous replication because it is both of the nodes are communicating with each other to ensure that the data that is being sent from one side is getting written to the secondary node. On the other hand, on asynchronous replication, the primary node just doesn't really wait for the secondary node to send confirmation to it before it sends more data to get written to the secondary node. And in asynchronous replication has this advantage that it has no latency. So latency is really low in asynchronous replication, but we could experience data loss in asynchronous replication because the primary node is not really waiting for the secondary node to confirm that the data has been received. So these are different types of replications that are part of the clusters. And then we have this, and then we have actually, this failover situation, which happens when we have a failure in our system, or or we could perform the failover in a planned way to perform, like there could be a certain activity that is being scheduled, so we need to perform failover. So what actually is failover? Failover is basically when the primary node in our cluster becomes unavailable. So we have a variety of nodes in our cluster. We let's say we have three nodes in our cluster. So one of the nodes is primary, and that is the primary source of data in our cluster. But what if the primary nodes become unavailable? We need a way to shift the client request and to the availability of the cluster to a secondary node and make the system high available and cater to the client request all the time. So first of all, we need to detect that the primary node has become unavailable, and once it has been detected, or maybe in planned failover scenarios, we turn off the primary node ourselves, or we shut it down for some certain activities which are planned. So in any case, if the primary node becomes unavailable, or it is being shut down, or there's a disaster that it is not able to perform its operations, then we need to transition a secondary node from the secondary role to a primary role. So in that way, we could resume the operations of our cluster without any delay and without any significant delay in the service. And even if one of our node is down, it doesn't really matter because we have two other nodes to cater to the client connection request, and we could just resume our operation and service without any without any without any delay in our system. The failover process in itself may take about around 10 to 30 seconds, and that is the time when which the which the secondary instance takes from to transition into the primary node. So there are basically two types of failover: planned failover and unplanned failover. So what is planned failover? Failover is when you need to perform a scheduled activity on your database. So what is a scheduled activity that you can perform on a database? Maybe you need to perform an upgrade on your database, or maybe you need to just simply change the schema of your database, or any type, or you need to perform any other change on your database. And while you're performing those changes on your database, there could be a downtime in your service, and to avoid that downtime, you shut down your node yourself and promote another secondary node to the primary role to ensure a high available database system. So what happens is that you schedule your activity for a certain time, and then you manually shut down so this is important to note that you're manually shutting down your primary node, and then you check that the secondary node that you are trying to promote to the primary role is has data synchronization with the primary node. So if the data is not really in synchronization with the primary node, then it could get become difficult because, or it could get problematic because then there's going to be service failure or service fault because the data is not really what it was originally on the primary node. So you check that the second node you're trying to promote to the primary node is actually in sync with the primary node, and then you shut down your primary node and then you promote the secondary node to the primary node. So what could be the cause of unplanned or component system failure? So the other type of failover that we have is the unplanned or unplanned failover. This is where you're not really anticipating the failure of a primary node, and this comes about as a surprise, and that could be caused by a variety of reasons, like maybe there was a natural disaster, or maybe there was a power outage, or maybe there was a system failure, or like hardware failed, or maybe there was a corrupt software corruption situation, or any about there are like a lot of reasons which could cause unplanned failure of a system of our database system. So unplanned failover is when your primary node becomes unavailable due to about any of these due to any from due to any reasons from these reasons, and that is when you need to that is when the failover of the secondary node is triggered automatically. So basically, when the primary node becomes available due to a disaster or maybe a power outage, the cluster detects that the primary node has become unavailable, and then it triggers the unplanned failover automatically by promoting a secondary node to the primary node level. And the synchronization is basically checked after the failover because we don't really have an option to accept promoting a secondary node to the primary node because our primary node has become unavailable and we need to cater to the client request. So we just promote a secondary node to the primary node level, and then we try to synchronize it if it's already not in synchronization, which is not really a case in most of the systems. Since if your application is working fine, then the most of the secondary nodes are in sync with the primary node, since synchronization is performed or replication is performed, like ideally should be performed multiple times a day. So how does failover actually work? So we have a client application which is trying to which is sending read write connections and read only connections to our database systems. So we have this router here, or maybe load balancer, which balances the load, which balances the request from our client application and forwards them to their respective nodes according to the type of connections to the type of connection it is forwarding. So we have when we are receiving read-write connections, it is going to the primary node, and when we are receiving read-only connections, they are going to the two secondary nodes that we have. And at the bottom, we have replication activity that is being performed from the primary node to the secondary node. So all of the read-write connections that are coming to the primary node are modifying the database in some way or other. And when the database is being modified, and if the database was originally the same on three nodes, and a client request comes which is of read write mode, and it writes something to the database, the database changes, and we need to copy that change to the secondary nodes through some way. So replication is doing exactly that, and it's copying that change from the primary node to these two secondary nodes. So this is what's happening in a cluster basically, and now we have a service failure on the primary node. So the primary node becomes down due to any reason. Maybe there was a power outage on it, or maybe the server shut down due to some reason. But anyhow, it is not available anymore. And now the client application which is forwarding the read write connections are like cannot go to any node because the primary node has become down, and the replication activities is also stopped because the primary node is not receiving any connection request and it cannot originate the replication. So what happens next is that uh, the secondary instance is become, it gets shifted to a prime role. So this secondary node is promoted to the primary role because the original primary node had been unavailable. So there are no more client read-write connections getting sent to the primary node because it is currently unavailable, and the new primary node is going to cater to the read-write connections. And that is where their application is also going to originate from towards the another secondary node, which is still part of the cluster. So the read-only connections are still going to be catered by the secondary node, which was there, but the read-write connections are going to be sent towards this new primary node, which just got promoted to this role because of the unavailability of the original primary node. So now we have so you see that the cluster is still through cluster we are offering high availability to the users because even though one of our node became unavailable, there was literally no effect on our service, and the service continued smoothly, and all of the connection requests, whether they were read write or they were read only, are still being catered to the users. So after some time, or maybe after some troubleshooting, or maybe there was some power outage and it resumed, the original primary node is back into the cluster, but now it has been demoted to the secondary role because now we had a new primary in the cluster. So now when the client requests are coming in, the read-only requests are going to be forwarded to this node as well, because now it's the secondary node, so it's going to work as the secondary node and it's going to receive the read-only connections, and and the read-only connections are going to be received by these two secondary nodes, and the read-write connections are going to be received by this new primary node. And the replication is now going to be originating from this node in the middle, which will act as primary in all form, like in every way. So the data that will get written to the database will originate from this node, and it will get written to these two secondary nodes. So how does failover work? So first of all, we detected the unavailability of the primary node, and we saw that it has stopped working for any reason. We don't really care what's the reason. What we care about is that it has stopped working, and we need to make our system quickly available back. We need to take our system quickly back to availability. So what happens is that once the unavailability has been detected in the primary node, a failover is triggered to a secondary node. So a secondary node, which is selected at random, or maybe for some factors, which is like health check or something. Um, so we perform health checks and or maybe synchronization checks or anything like that, and we check that which of the secondary nodes is in the best position to take the role of the next primary node. So once the original primary has become unavailable, the next thing that happens is that a secondary node is promoted to the primary node. The third step is that the read-write requests are rerouted from the original primary node to the new primary node. So originally we had the node 1 which was catering to the read-write request, but after it became unavailable, and after the node 2 was promoted to the primary node, the read-write requests are also rerouted to the node 2, which has become the new primary node. The fourth thing, the fourth step, which is part of the failover process, is the redirecting the secondary node's replication from new primary. So the replication was originally originating from the from node 1, which was the primary node, but after it became unavailable, we and after the new primary node has taken its role, the replication starts originating from the new primary, and it goes towards the two secondary nodes which are now part of the system. And after we have done rerouting and rewriting, the initial primary node is restarted, and it becomes part of the cluster again as a secondary node. So that is how a failover process work, and that is how a cluster is a source of high availability in our database systems. So you see, even if if there's a if there is a failure of in one node of any type, then a cluster through a cluster we could just about deal with any type of failure on on that system, and we could just easily recover from that service unavailability by promoting a new another secondary node to the primary node, and the service continues. So that is how basically database clusters help us in achieving high availability in our systems, and that is what high availability is all about. It's about you know uh, providing availability to the users, no matter what type of failure are being faced at the back end. So that was it. That was just that was how we achieved high availability in our database systems, through database clusters, through redundancy, through replication, and through failover. That's it.
Awesome. That was quite impressive. I found a lot of new things to learn. So yeah, it was quite insightful. All right. If anyone has any question, so please post it. Otherwise, we can end the stream. Let's wait for a minute or two. So if
Okay,
anyone has any
sure.
question. So looks like yeah, we do have a question. Which is, can you let me know why we can't have two nodes in a cluster?
I think you mean that why we can't have two primary nodes in a cluster, because we do have the cluster that I just displayed. We do have three nodes in a cluster, but since you're probably asking that why we can't have two primary nodes in a system, we do have a mode of cluster where we have two primary nodes in our cluster, and the type of cluster that I was discussing is basically a active and passive mode of cluster where we have one primary and multiple secondary nodes. But we can surely have two primary nodes in our system as well. In which case, when we have a service failure on one primary node, the service is basically the read write connection requests are basically rerouted toward another primary node, which is part of the cluster. Do we have any
Hope
other
that
questions?
answered your questions.
Yeah.
No, not at the moment.
Okay.
All right, I guess that is it. Thank you everyone for joining and tuning in, and thank you so much, Kenza, for giving this insightful session. So that is it for today. See you, folks, next time. Have a great
Thank
weekend.
you
Have a great
for
Sunday.
Thank you for inviting me. It was really good being here, and yeah, have a great weekend, everyone. Hope it was an informative session.
All right, bye, folks.
Bye bye.